Hello, my name is Christian Glenister. I am a current strength and conditioning coach based in the UK and current head coach and owner of Functional Strength UK, a small strength and conditioning facility. I will be producing today a velocity-based training lecture, trying to give about a half an hour spiel on how velocity-based training is used within the weights room these days, how we can use it to influence um, recovery, how we can use it to influence performance and all different metrics, and also a bit of the history and origin of where it's come from. So most importantly, let's start with what is velocity-based training, or VBT for short. Velocity-based training, as you can see there, is a quantified weight training. So essentially what this does is it measures and delivers key data within a split second or click of a button, depending on what device you're using. The whole point of using velocity-based training is to help increase performance qualities that are needed across all sports. So looking at speed and velocity, force, power, etc. These are key elements, and this is something that can be tracked using velocity-based training. What's essential, and I will keep on hitting on this throughout the whole lecture, is that this is not a this or that scenario. Velocity-based training is just something we can add to the toolbox to make us better coaches in certain areas. It can save us time and make us more efficient. Essentially, it helps us manage anyone that walks through the door with the utmost professionalism, efficiency, accuracy, and most importantly, we can manage them as an individual down to the nth degree, as we've got a little bit more detail and data to extrapolate. So once again, it doesn't mean you have to be percentage-based training or velocity-based training. Velocity-based training is something that can help boost your typical strength protocol, so long as we're using it correctly. So the history and origin of it, we're going to go way back. We start looking at, well, this is speed and the whole concept of it. So Galileo, the Italian scientist from the 16th century, he was credited with discovering the concept of speed. Obviously, speed has always been around in terms of how he discovered it as a concept, is pretty much credited to Galileo. So speed is typically measured in what we say meters per second, what we look at here when we're using velocity-based training. And this is the rate at which an object is moving. Velocity, which is what we like to use as a term, is how fast the object gets somewhere with respect to its direction. So it's basically speed equals distance over time, and velocity is distance over time. So what we're looking at here is where does the object start and where does it get to, and the amount of time it takes to do that in that certain direction. Think of a squat or a bench press. Then moving forward a little bit more, physics comes into this a lot, so I hope you're ready for that. But Newton's second law, also known as the law of motion, this mentions acceleration throughout that second law, and essentially it's all about the acceleration. The way that's worked out is basically all dependent upon the object and the net force placed upon it. So the greater amount of force placed on the object and the mass of that object all comes into the calculation of acceleration. Think of having a push bike or a car. If you were to produce the same amount of force you did for the trying to push a car with your legs and hands and try and put that over onto a bike, the bike would accelerate quicker just due to the mass of that object. So the amount of force needed will always depend on what the object is and the mass is, and that comes into weightlifting a lot. And then into more modern times, we look at who's been credited with the more modern research, if you like. Vyshansky, Roman, Bosco. If you look back at the special strength training manual of Vyshansky, this obviously mentions speed and dynamic movements, and it's essential that velocity's always been tracked. However, now we've just got equipment that can track it really accurately. We look at exactly how fast it's moving. Coaches since the Soviet days have always been looking at the speed at which an athlete moves. We can just do now with a great deal more accuracy. And then even more modern, we can look at Brian Mann, who has done his PhD in velocity-based training as well. And he's come up with the velocity-based trainings that you'll see, zones, that you'll see here below. Now, the use of velocity-based training zones has led to power increases for a greater number of years. So if you just did percentile-based training versus percentile-based training with velocity-based training, with velocity-based training, is leading to longer gains. So you may get the same amount of gains, the same amount of power increase, but it will last longer with the use of velocity-based training zones. And this comes down to a few factors that we'll mention later, but these zones are credited to Brian Mann. So we're going to get into the sort of meat and veg of it, is how, why, and when to implement velocity-based training. One of the most key factors that we like to look at and use is the intent behind it. This doesn't look all that scientific when you say it, and essentially it's not. We always want our athlete to move with as much intent as possible, but why? And then we can look at how we track that. So when you're training for strength and power, it's essential the intent to move the load, the mass, is nothing less, than 100%. Essentially, the athlete has to give absolutely everything to make sure that we're getting the appropriate strength and power gains that we're looking for and the adaptations that we want. By trying to lift the weights as explosively as possible, an athlete will accelerate and increase the recruitment of their largest, most powerful type 2 motor units. And this is due to something called the Henneman size principle. Now, the Henneman size principle, we're not going to go into a great deal of detail on this, as most people will be familiar with this. However, if you're not, essentially breaking it down into layman's terms, the Henneman size principle means using fatigue-resistant muscle fibers first and only using fatigable fibers when higher amounts of force are needed. So how does that apply to sport, and what does that really mean? If you think about this Henneman size principle, it essentially means, imagine jogging around the field. You are using the fatigue-resistant muscle fibers when you're producing that task. Then when a large tackle is needed, a jump is needed, or a quick sprint and change of direction is needed, the fatigable fibers are used then because that's a higher amount of force needed. However, those fatigable fibers are only needed for that quick amount of work needed when the ultimate amount of force needs to be produced. So why is that key? Velocity-based training. Well, the Henneman size principle, believe it or not, can be accelerated, or we can even increase the recruitment of the largest motor units by training it as explosively as possible. So you can train your body to recruit those muscle fibers or those motor units as quickly as possible by training more explosive models of movement. So, for example, loaded jumps, Olympic weightlifting derivatives. These are all explosive movements, even ballistic movements and plyometrics. This in turn trains our body to accelerate and increase the recruitment of the largest, most powerful type 2 motor units. So that's how we get the Henneman size principle trained and more efficient. That then carries over to whatever sport we're doing. As an example here, you can see I've got one of the fighters, Adam. It's very key that in the split second, he is able to make a decision where he can land the blow, a kick, whatever it may be, on the opponent. To be able to do that, he needs to be able to fire quickly by lifting weights as quickly as possible in the weight room and then drilling his technique day in, day out in the gym, in his fight gym. We're able to sort of complement each other. So he's working explosively in the gym and explosively and technically when in the ring as well. And those two things can marry up so we can produce as much as possible. For an example here, I've got a picture or a screenshot of his front squat and the amount of force he's producing. Then hopefully I can track that, keep an eye on that, and look for him to move as quickly and as explosively as possible. So what does this all mean? And getting a little bit more detailed into it. So the higher intent in training increases the rate of force development. Rate of force development is just the speed of which force is developed. So we can do a squat at 100 kilos at 0.5 meters per second, or we can do a squat at 100 kilos at 0.75 meters per second. The second option, the 0.75 meters per second, means that the squat has been moved quicker, or the load has been moved quicker from top to bottom. And now this means we have produced force at a quicker rate of force development. This is down to rate coding. So how fast are we sending the signals down the nervous system? By training with as much intent as possible and as explosively as possible, we are then training our body to send the signals down the nervous system quicker and more efficiently. We're then preferring the type 2 muscle fiber and hypertrophy through the SAID principle. The SAID principle stands for specific adaptations to impose demands. So if I want the athlete to become more powerful, if this is something they're trying to achieve, they need to achieve more power in their movements, then by tracking on velocity-based training, I can make sure that they are becoming more powerful than they once were by looking at the previous figures. So as that previous example I gave, if a squat was moving at 0.5 meters per second, but now moving at 0.75 meters per second on the same load, it means that I've tracked that squat and we're now moving quicker. It means he's producing force quicker and therefore he's becoming more powerful. If that is what we set out to achieve in that block, that means the said principle is exactly what we've wanted to happen. So we've had specific adaptations to the imposed demand. Tracking intent has always relied upon a keen coach's eye and still should. We shouldn't be staring at our phones or the technology the whole time. However, the ability to track and monitor objective metrics such as velocity and power has become a key coaching tool now, and we can now look at this in greater detail. The more detail and data we have, so long as we use it efficiently, means that we can then provide even more motivation for the athlete. So if an athlete is doing power cleans and we're looking at a certain speed at which they're moving, we can keep that phone in front of them, or a coach or an athlete or training partner can be reading and feeding this back directly to them. And they can tell them they are moving at a certain speed. In between each rep, they may use this as motivation to try and beat that previous speed, and therefore improving the training adaptations and reinforcing this higher intent to training. The intent is so key. Without the 100% intent, we're not going to get the results that we want. So other ways that we can look at now using and implementing velocity-based training. We've covered intent. So now we look at estimating 1RMs. Essentially, it's not always what we could call efficient to test an athlete's 1RM in a movement, but we can use something called minimum velocity threshold for an estimated 1RM and using a load velocity profile. This is an example of a load velocity profile here in front of you. This is done on a bench press. And the athlete produced three different sets. Each one was of 3 reps. So here the athletes produced one we chose a fairly light load to begin with, and that is in the blue dot, and that moved at approximately 0.7 meters per second. The second set was at 60 kilograms, and that's moved at approximately 0.5 meters per second. So it's getting a bit slower as the weight's getting higher. And then the last one was 80 kilograms, and this moved at just above 0.3 meters per second. So as you can see, they've gone down in a linear fashion. Now, why that's important, we'll come into it. There's a minimum velocity threshold for each movement. This will always remain constant. Essentially, this means the slowest the weight or the mass can move without being unsuccessful. So the studies have shown that the slowest that a bench press can move, unless you're a highly trained power lifter, is around 0.17 meters per second. So that green dotted line will always remain the same. And where that green dotted line meets that black decreasing linear line will give you an estimated 1RM. So without having to push the athlete to a 1RM, what we have found is that you have an estimated 1 rep max of 100 or nearly 100 kilos. I think it's 98 kilos. So this is ideal. So this means I haven't had to push the athlete to 1 rep maximum. It just means that I start off at a light load, we move it, then we put a bit more weight on to try and slow them down. Ideally, we should see this linear fashion. You can complete more sets if you wish. It doesn't have to just be 3, but anywhere between 3 and 5 is usually decent. And we're looking to slow to the point where the athlete produces around 0.3 or even lower, but around 0.3 meters per second is good for that set. This will give you a fairly accurate 1RM. This is a fairly accurate 1RM because I know this athlete and it's been tested on them before, and they have a 1RM of 100, I think it's 102.5 kilos, and that gave an estimated 1RM of 98. So it stole 4 kilos off him. I get that, but it's still a fair degree of accuracy without having to push him to the 1RM. Why wouldn't we want to push him to a 1 rep maximum test? Well, we look at fatigue. You've got to remember the athlete is not a bench press specialist. They'll be using bench press in this scenario to try and improve their rate of force development through the upper body and the amount of force produced. So if I can do that, still gain some good metrics, and then be able to move on without fatigue to their sport, that means I've done my job as a strength and conditioning coach. Also, it allows me then to look at this and give some planning data to the athlete. So if they were to train on their own, I could tell the athlete, I want them to move 40 kilos on the bar. This could say, why have you given me 40 kilos? And I'll say, this is down because I want you moving at around 0.7 meters per second. Now, that speed could change depending on whether the athlete's having a good or bad day, but it would be a really good estimation of a weight to use if I'm not there and the athlete doesn't have the velocity-based training kit. From this graph you can see here, I would be able to recommend certain weights for certain zones, and I could be fairly confident they're moving at a speed that I would want to get the adaptations. Those zones all come from Brian Mann, and we'll discuss them soon. So further things we need to look at now is for the how, why, and whens. Monitoring progress through velocity and power output is another reason why we can use it. If I was to have an athlete do bench press, as we've just seen, and they were to move 80 kilos at 0.3 meters per second as an average, then after a good training block, they could move that at 0.6 meters per second. That means they've improved the rate of force development and power output and velocity. So it doesn't always have to mean an increase on the bar, even though that is more satisfying for a lot of people. You can always have this where you can have the athlete produce the same sets with the same weight. And as long as you see an increase in that, you know you've done your job and they've become more powerful and produce more velocity on that bar. Auto regulation. So this essentially just means looking at how we regulate the athlete when they come in. Are they fatigued, etc. So we look at warm-up sets to monitor the fatigue. I could have that athlete produce the normal warm-up sets, and in and around second to third sets, we can monitor the speed at which they move over a couple of weeks, and we should have an average speed at which they move their warm-up sets. If one day they come in and they're well below that average speed on their warm-up sets, this could be a sign of fatigue, and then I can adjust the training program to make sure that we don't push that fatigue any further. Likewise, on the other hand, if the athlete is moving those warm-up sets a lot quicker, it means they could be having a good day and it's time to get a little bit more out of them. Essentially, do your cooking when the fire's hot. And then velocity loss for auto regulation. So we can set velocity loss on our velocity-based training devices. We can say we don't want the athlete to drop below a 10% velocity loss. So we've put a 0.7 meters per second. We can then set the velocity loss for 10%. And this means that if they drop below 10% of that speed that they're producing, then it's a cutoff. So even though I might have asked for 5 reps, if they get to 3 reps and then on the 4th, they've dropped 10% below the speed, we give them a cutoff and we say, that's you done. And that minimizes fatigue. Once again, they're not coming in to be weight specialists. They're coming in to use weights to boost their performance for their sport, for which they cannot be fatigued. Real-time fatigue. So we can look at the minimum required effort. What is the stress intended and DOMs? I can set speed and tell them we need to put in, this is the minimum effort we can have, and I don't want you to drop below that speed. We can look at where are we in the season? So what is the stress intended? And we can look at the DOMs as a result of that. If we've got a rugby player, for example, if they're pre-season, we can afford to put a little bit more stress through them, which may elicit more DOMs and muscle soreness. However, if they haven't got a game that week and we can afford to put them under that stress, where we can allow them to be a little bit more fatigued and sore for a couple of days or maybe the day after, that's okay. However, if I'm eliciting large amounts of stress and DOMs 24 hours before a game, then that's poor practicing. And we need to make sure that we are looking at where we are in the season, what is the intended stress. And velocity-based training helps us do that with the speed monitoring. It gives us real-time feedback, motivation and competition. Motivation and competition is great in a gym, so long as everyone's technique is squared away. We can have multiple athletes doing squats, sharing the same bar. They could all be doing one set of 5 at 80% as an example. And we can all those weights might be different, but it's relative. It's 80% of their 1 rep maximum. So we can ask them to push that velocity as high as possible. If athlete A manages to achieve 0.6 meters per second as an average across 5 reps, athlete B might come in and go, right, I need to try and beat that. And that provides good competition. So long as technique isn't being compromised and the lift and the integrity of the lift isn't compromised, then it's a good thing. Once again, we can use it for testing 1RM, but not just estimated 1RMs. We could use it to test peak power, peak velocity and mean velocity. If an athlete completes a 1RM test or an estimated 1RM test, we could look at what was their peak power during that set, that peak velocity and mean velocity. And then the next time they complete it, even if they use the same weight, has that peak power, velocity, and mean velocity increased? If so, like I mentioned before, then we've seen an increase and we've done our job. Good stuff. Real world application. So here we can see the All Black training devices. We're measuring counter movement jumps along with bench press. Absolutely fantastic. A real good example of how you can see the intent from the athlete. I've also put down the left here of the sport currently. That's just a very small handful. You can see a wide array of sports. It's not very specific to one sport, and it's been incorporated across more real world application. Let's have a look at this. This is just me using 50 kilos this morning as an example. So when I did this, you can see I did 3 bench press. Now that gave me an average of 0.77 meters per second. It's really good feedback. So how am I going to use that? Well, if you then look to the table at the right, it gives me not just the speed at the end, but then I can click on a table and it gives me the overall mean power of that set. You can see set 1, I was 387 watts. Set 2, I saw an increase to 432 watts. But set 3 and set 4 started to diminish a little bit to 407, 402 watts. Okay, so this is where you can go, right, that athlete's fatiguing, cut off. But as you can see, I've written on the right, on the left there, know your athlete. So knowing your athlete, do they just need to push on a little bit more? Do they need a bit more encouragement? Okay, and a little bit of a kick up the arse? Or do you know that they're fatigued? Can you read the real world signs? Do you know your athlete well enough? I know myself well enough to know that I just switched off. I then switched back on again and did a third set. And you can see that I got on that third set, not far off the same wattage I got on my second set, which is great. So my very last set was my second highest score as an overall mean power. That's just because I knew I could do it and I was just switching off a little bit. Then we can have a look at the whole choice of metrics depending on the device you use. My device offers me all these different metrics here that you can see. So I have to choose the right tool for the right job. Am I looking at peak or mean velocity, peak or mean power, relative power, force, which measures in newtons, relative peak force, work completed in kilojoules, or vertical displacement? It all depends on what is the movement you're doing, what phase you are in training. Velocity loss that I mentioned before is a real world example of a rugby player doing trap bar jumps. I've told them here that we've got a 10% velocity cutoff. So the athlete is going to keep on doing jumps until they've dropped below 10% of their first rep. You can see here that we started increasing. I can look at the speeds, and also we completed a new PB there. So I only need 1 set of this. This lets me know where the athlete is, and it's a great power endurance tool. 1 set, and I've got lots of data, and we managed to complete 11 reps. I saw the cutoff was after, I believe, 9 reps there. So yeah, the cutoff was after 9 reps. He completed 2 more because he didn't hear me. But we've managed to measure our meters per second. We've managed to measure our mean wattage. And also, I've got some good data. I know that on an empty trap bar jump, he managed to complete 9 reps before falling below his first rep. Then we start looking at the force velocity curve, something we're all familiar with. So we're looking at maximal speed for maximum velocity, maximal strength for maximum force. What does that look like? Well, if we're looking at maximal speed, we should be moving it around 1.3 meters per second or higher. Maximum power around 1 to 0.7 meters per second. Maximal strength is usually below 0.5 meters per second. What does that mean? So your maximal strength zone, using a very heavy load, ends up being a slower movement. Power, which is 0.7 to 1 meters per second, which is a moderate load, moving fast, prioritizing strength over speed. When we move to speed, we look at moving a minimal load as fast as possible, prioritizing speed over strength. Why are these zones important? Well, depending on where you are. It's very key in your season or in your session or in your block of training to know. Helps with periodization. Different devices that are available. You've got the gold standard of lab-based 3D motion capture. If this is something that you use, you're a very lucky person. Essentially, like I say, they're lab-based, very expensive bit of equipment, golden standard. Multi-camera systems are also very, very accurate. You need to have friends in high places usually to have these. You've got the linear positional transducers, or LPTs. This is like the gym aware. This is the stuff that you see. We've got a thin wire or cable connected from the collar down to the bit of equipment. And then the very accessible bits of kit that I use, for example, is wearable technology and accelerometers. This is stuff like the output or push bands. If you want any more information on this, just email me and I'll give you it. Benefits and drawbacks. So the benefits, let's get into it. Athletic performance quality is increased. Distinct improvements in lower limb maximum strength, power endurance, strength endurance, sprint performance. And these are according to the studies that have been shown. Okay, so there are studies to back up this information that all those metrics are improved. This studies that I've read, they said among trained males. Delve deeper, you'll find that it's also apparent in females. It improves the neuromuscular performance recovery. So neuromuscular performance recovery is faster post low velocity loss resistance training. So if I aim, like I was showing you with the athlete before, doing the velocity based training, and he was doing the trap bar jumps, if I gave him a very low cutoff of 5%, that really helps minimize the amount of time he needs to recover, as we are really, really stopping any amount of fatigue kicking in. A 5% is a very, very low cutoff, but the lower the cutoff, it means the quicker the recovery. And if you're in season, that's important. Sport is always going to be greater than the weights room. We have to remember that. For the athlete, VBT or velocity-based training is there to help and not hinder. It feeds competitiveness and drives progression across loads of different metrics. Use the right tool for the right job. And it includes the athlete in the process. So an educated athlete, I usually find, is a well-driven athlete. If you tell the athlete why you're doing what you're doing, they'll usually buy into it and they'll give you a little bit more results. Some of the drawbacks we can see, these are just things I'm trying to think of the top of my head, but you can become too reliant upon it. If you're using it for every single movement, every single rep of every set in every session, then maybe you're not using your coach's eye enough. You don't want to be sitting there with the phone in your hand all the time rather than pay attention to the athlete. Don't neglect the basic principles of strength training. Takeaways. We've got to remember, it's a nice to have, not a must to have. You have more data to draw from, but you have to be able to use that data effectively and efficiently, not take more time away from the time in the gym. It's for progression and fatigue management. So this isn't something where it needs to be lived off for the rest of time. We just need to use it to help our progression and fatigue management across certain areas. Sport is the priority. Let this be another tool to your already well-trained coach's eye, another feather to the cap, etc., etc. You have developed a wealth of knowledge as a coach, usually, if you're a strength and conditioning coach, and it's important that we build upon this. The athletes that we have, we need to use our wealth of knowledge. We need to apply it all to them. And then how can this help it on top? Just another layer to the cake. Here's a few references just to go in that I've used to help compile this small lecture. And just a quick thank you as well from Your Gym Sports Performance with Tom and Martin, who have helped me push on to produce a few of these lectures. And they also run strength and conditioning courses if you're interested to become an accredited strength and conditioning coach. I hope you've enjoyed this. And if you want to get in touch to discuss absolutely anything, that's fine. I've tried to make this as understandable as possible for the layperson. And this isn't a hard line in the sand of the do's and don'ts. This is more just encouragements to try and get involved and hopefully give you a little bit more information on velocity-based training.